Hi, my name is Lee Richard, and I have been running track since I was 9. So it makes sense that I create a passion project based on a topic I am familiar with. For each page of my passion project, I produce a new driving question where I would then do research, deriving of equations, and experiments to find the answer to my driving question. At the bottom of this video should have the link to this project. This page is the introduction and research section for part 2 of my project. My driving question is, does the runner's starting position affect their performance of speed? In research, I found that if you want to be a faster sprinter, you should work on your angles. For example, when coming up the blocks, you need your leg angle to be a 2-point angle between radius of leg center of gravity and a horizontal line to make a 90-degree angle, followed by higher vertical foot velocity and for the rest of your back to look like an airplane coming off the ground. Here is a video for an example, and here are my citations. Next is where my experiment comes in. The X component in my data means that I will not be running on hills or anything that will cause me to run vertically. I'll be running horizontally on a flat surface. I did 3 trials where in each trial I took off running in a different starting position and recorded how fast it took me to reach 10 meters. This picture is an example from the previous page on how you should look coming out the blocks. Additionally, here is where I compare my 3 trials to each other with their own velocity versus time graph, acceleration versus time graph, and position versus time graph. And as you can see, the y-axis for each velocity versus time graph stays the same because it represents distance in meters, where the x-axis, known as time, is different from each trial, which is how I can tell which trial had the faster time. For example, from trial 3, when I ran a distance of 20 meters, I finished in a time of 4.2 seconds, where in trial 2, I ran a time of 4.3 seconds in 20 meters. So as you can see, I ran a faster time from starting position 3 than 2. In my acceleration versus time graph, the y-axis represents my constant speed in a perfect world with no outside forces or vectors at play, meaning that is how fast I would run for 21 seconds if I did not get tired or if the wind got stronger. Lastly, the position versus time graph on the y-axis is to depict my motion with position based on how I started, which is why I added a longer distance so you can see the progression. Furthermore, here's where the physics and deriving of equations comes in. I derived the kinematics equation to solve for velocity, acceleration, and air resistance. I found the air resistance by converting the miles per hour of wind from that day and time to meters per second. I found velocity by dividing how far I ran by how much time it took me to complete those 10 meters. Then compared the data and found that the most efficient starting position was my third trial, the necessary starting position. And that's it. Thank you.